right, one more example of a problem involving power. We have a sports car accelerating from 0 to 15 meters per second in 1.5 seconds. How long does it take for the same car, to accelerate from 0 to 30 meters per second, assuming the power of the engine to be independent of velocity and neglecting friction? So power, we're talking average power here. So power is the work per time. So how fast this car is creating kinetic energy from the gasoline, the functions that are happening within the car. So the work being done is giving the car its kinetic energy. So I'm essentially using the net work being 1/2 mv final squared minus 1/2 mv initial squared. But this car is starting at 0. So that net work is giving the car that kinetic energy in that amount of time. Since we're assuming the power to be independent of velocity and neglecting friction, we're essentially just assuming the power to be the same, regardless of the 0 to 15 meters per second versus 0 to 30 meters per second. So we could totally plug in this 15 meters per second and the 1.5. We won't get an actual number because we don't know the mass of the car. But since we're assuming the power to be constant, we can say 1/2 mv squared, whatever kinetic energy the car reaches versus per time is going to be the same. So I'm going to say 1/2 m, I'm just going to call this a V1 and a T1. So that power in situation 1 needs to equal the power in situation 2. So V2 is the 30, T2 is the time we're trying to find. When we set it up as an equality, the 1/2 and the m, those cancel. We're looking for T2. So if I cross multiply, I'm going to have V2 squared times T1 over V1 squared. So 30 squared times 1.5 over 15 squared. So 6 seconds. By the way, the 30 over 15 becomes 2. This becomes 2 squared times 1.5. So it takes 4 times longer because of that velocity being squared.